Hello everyone, welcome to Programming Knowledge. So I again welcome you all to yet another tutorial at Programming Knowledge. So in today's tutorial we are going to cover with some few techniques with strings. So these are going to be very important techniques with the strings. You can refer to our repository, and before you will get all the codes implemented in Python prior to this tutorial. So here you can see today we are going to do some important work algorithms in the strings. So basically strings with hash maps is our key point. Basically we are also going to cover few things as well. So here you can see you can move to our GitHub link of the repository. This is the GitHub link and you can find the codes. So let's start with the tutorial. So let's first implement our first program, that is define is palindrome. So this would tell us if the string is a palindrome or not. So we can do this in one line. Return s is equal to s of reverse string. So this would help us to find if the string is palindrome or not. So here you can see what it does. It takes a string as a parameter and it then returns the reverse of the strings. And this does the reverse of the string, and we check whether both the strings are equal or not. So basically, we are checking if the string is equal to reverse of the string or not. So let me call this function print is palindrome s1, and simply again I'll call this for print is palindrome for s2. So I'll take two strings s1 and s2, and you would be able to get our idea. So let's run to the test cases. This is the two strings. Here you can see that both of them are palindrome. So let's move to the test cases. Yes. So let's run this program. Okay, there is an error. I had to put the quotes. Yeah. Now you can see. Sorry. Yeah, both of them are true because both of them are palindrome. So let's move to our next program, that is anagrams. Here you can see these two words, silent or listen. They are just a permutation of each other. Here you can see that both of them comprise the same alphabets, that is L-I-S-T-E-N, and here you can see L is here, I is here, S is here, T is here, E is here, and N is here. So we're going to check if the two strings are palindrome or not. So let's define a function. Define is anagram, and we take two strings s1 comma s2 and simply return. There are two ways of checking this. First we can do return sorted s1 is equal to sorted of s2. uh, I'll also sorted print sorted s1 and print sorted s2. uh, Here also we could also print s comma s of minus minus 1. So this would give you a very clear overview how this algorithm works also. Print s and print s of minus minus 1. Yeah. So let me run. Here you can see the s is same, then s of minus 1 is same, then we get a true, then same for this one. Let me do this for the anagram also. So I'll define a 2, and I need to put these test cases here, and I'll give the codes silent and listen. So here you can see, and I'll call the function print is anagram s1 comma s2. Here you can see that after sorting both the silent and listen, after sorting both of them I get the same alphabetical order, and this is how I predict that if it's an anagram or not. I can do this using another method. Let me show you what you can do. This time complexity of this program was this time complexity of this program was n log n, and the space complexity uh, uh, it depends, like if there is a sort function takes in place, Then here you can see, let's assume that time complexity is n log n. I can do this in time complexity of n. How? I'll tell you. Time complexity of O of n, and this was O of n log n, and the palindrome function also took O of n time, because it only reverses the string. So here I can move with the uh, uh, O of n algorithm. What you can do from collections, from collections import counter, and now then I'll print counter of s1 and counter of s2. Then instead of sorted, I'll return counter of s1 is equal to counter of s2. Basically, counter is a hash map only. What it does, it gets the frequency of all the characters in the string. So I'll run this program. Here you can see the S occurs one time, I occurs one time, L occurs one time, E occurs one time, N one time, T occurs one. So every character occurs once. So it compares the frequency, that if the both the counter are equal. So here I can say that this is also an anagram. So let's again move to the next program, that is frequency sort. Okay, before that, let's move to another algorithm. I'll add here, that is sort by length. So sort by length is, you can take any string, hello world, welcome to programming, and then you can say, welcome to programming, happy coding. So this is a string. So here you can see that this is a string. So let's take the string. So sort by length is we can add this to a tutorial, because it's good. Sort by length. So sort by length is basically, by length I mean that we are going to sort the string by length. So let's take this. S is equal to, our string is this, hello world, sort by programming. So what we are going to do, print sorted. Uh, what I'll do, first, what I'll do, I'll make an array. A is equal to s dot split. So basically this would split the string. Now I would, what I would do, sort the words of the string by length in descending order. Perfect. I hope it's perfect. So I would sort the words of string by length in descending order. And what I'm going to do, a dot sort key is equal to length, and reverse is equal to true. Key is equal to length, because I'm specifying that you sort by length, and reverse is equal to true. Then I would print a. So here you can see that the word with the like maximum length is comes first. That is, the programming has the most, is the word with the maximum length. Then welcome, then coding 5. The welcome, here you can see that it has 1 2 3 4 5 6 7 letters. Then I have 6 letters, then 5 5 and 2. So that's perfect. Okay, now let's take another program. uh, this is a string. We'll do frequency sort. So now sort by frequency. Let's do this. I'll take a string s and take programming knowledge. Now I'll call the function from collections import counter. I'll call the functions counter is ct is equal to counter of s. Now I'll define print ct. So here you can see, now I've got the frequency of each character. But what I'm going to do, I'll convert this into A is equal to ct dot items, and this would be a list. Now I'll do print A. So here you can see that now I have got the frequency of each character in a tuple manner, which is inside a list. That P occurs once, and every characters I've got which occurs like you can see that G occurs 3. Let me trace out where G occurs 3. This is the first G, second G, and third G. So this is now I want to sort this array. So simply I'm going to sort by frequency, that I will do a dot sort and key equal to lambda x, and I'll take x of 1 because x of 0 is character and x of 1 is the frequency. Then I can print a. So this would sort by frequency. Here you can see now the g of 3 comes in the end. And if the what I can also do, I can modify this to if x of 1, if the frequency is same, then I should sort them lexicographically. Then I would put x of 0 here. So here you can see, yeah, if the frequency is same, that is 111, then I sort them lexicographically. So this makes it the sort perfect. That first you sort by frequency, and if the frequency is same, then you sort them by lexicographically. So we covered four important programs in this tutorial. First is palindrome, anagram, then again anagram, sort the words by string by length in descending order. So time complexity of this one was n log n, and the last one was also n log n. So thank you guys, thank you so much for being in this tutorial. So I'll catch you in the next tutorial. So thank you guys, thank you so much.